Good morning everyone. Today we are going to learn about the sign convention for spherical mirror. This is Cartesian pen. I think all of you are having idea about this. We will use to plot the graph in xy plane. You know how to draw the coordinates for positive x-axis, negative x-axis, positive y-axis, negative y-axis. Above the origin, positive values. Below the origin, negative values. Right side, positive values, and left side, negative values. See, if we draw a spherical mirror here, and how for the values, how can we say in front of the mirrors all the distance or all the values should be taken in negative. Behind the mirror we need to take it as positive values, and above the plane object is there, it seems that we need to take it as positive. Below the plane we need to take it as negative. Clear? In front of the spherical mirror all the values should be negative. Behind the spherical mirror we will get positive values. Above the plane we will get positive, and below the plane we will get negative values. Now we will see how we need to take the values. All the distance must be measured from the pole. From here we need to pole. From here we need to measure. From the pole we need to start to measure the distance. See, here object is there, means from here to like this we need to measure up to from pole to this object. How much? That we need to write it as object distance. Clear? All the distance should be measured from the pole. Okay, and all the distance measured in the same direction of the incident rays are taken as positive values, and all the values taken opposite to the incident rays are taken as a negative. In the direction of incident rays we need to take it as positive. So if we are incidenting light rays like this, okay, if we measure the distance like this only, that we need to take it as positive. If we measure like this in opposite direction, that will taken as a negative. And distance measured above the plane and perpendicular to the plane are taken as a positive. Previous we have seen here. If I measure here, means here what you will get like this much distance. That means here positive values are there, no? So you will get positive values. If it is below the plane, then you will get the negative values. Object is always placed on the left side of the mirror. Object is always placed on the left side of the mirror. So the directions is from left to the right. All the distance measured from the pole of the mirror to the right side will consider as a positive, because they are in the same direction as that of incident ray. All the distance measured from pole of the mirror to the left side will be negative, because they are measured against the direction of incident rays. Incident rays are here and we are measuring from here, so opposite direction. Therefore we will get the negative values. Now we will see the ray diagrams of a concave mirror. There are three main rules are there. We will see the first case. As we know, this is the mirror, pole, focus, center of curvature. We call this as principal axis. Okay. If a light ray incident parallel to the principal axis, if a light ray incident parallel to the principal axis, After reflection, it always passes through the focus. If incident a light ray parallel to the principal axis, after reflection, it always passes through the focus. Clear? This is the first case. Second case, if the light ray passes through the focus, after reflection, it travels parallel to the principal axis. If a light ray travels through the focus, passes through the focus, after reflection, it travels parallel to the principal axis. Next, if a light ray incident along the center of curvature, after reflection again, it will retraces its path. Okay. And for your understanding, we can say principal axis and focus are both are friends. Whenever it goes out, always it will meet his friend. Okay, principal axis parallel. If incident a light parallel to the principal axis, always it passes through the focus. Similarly, if we incident a light ray through the focus, it always becomes parallel to the principal axis. Here, for center of curvature, again it retraces its path. For drawing the ray diagrams, we need to take any two from these three. We need to take, as we know, for incident ray, we need two light rays, right? For that, in these three cases, we need to take any two. Okay. See here, when we place the object at the focus of the mirror, we are taking one incident ray parallel to the principal axis. It is, what will happen parallel to the principal axis means always passes through the focus. We need two incident rays, right? One we are taking parallel to the principal axis, one we are taking from center of the curvature. For object, we need two incident rays. Where we will get the image? Where the two reflected rays will meet. See, they appear to meet at somewhere infinity. So, when we place the object at focus, we will get the image at infinity. What is the nature of the image? Real, inverted and highly magnified. When object is placed between focus and center of curvature. Previous we have placed the object at focus. Now between focus and the center of curvature. For that we need two incident rays. One same parallel to the principal axis passes through focus. Again one through the center of curvature. Okay, see here this reflected ray is meeting here, and from here this reflected ray is meeting. Means it retraces its path, right? So it will meet it here. Where the two reflected rays meet, we will get the image. See how we are getting real and inverted. Where we will get beyond the C, beyond center of curvature. How will the image real and inverted? Larger than the object. See, image size and the object size larger than the object. Next, when object is placed at the center of curvature, we need two incident rays. One parallel to the principal axis passes through focus. One passes through focus parallel to the principal axis. Therefore, the image size is same as the object size. But how will the image real and inverted? Next, when object is placed beyond the center of curvature, same one incident ray parallel to the principal axis passes through the focus. center of curvature, where the two reflected rays are meet here between focus and center of curvature. We are placing the object beyond the center of curvature. We are getting the image between focus and center of curvature, real and inverted, but the size is smaller than the object. Next, when object is at infinity somewhere here, one incident ray parallel to the principal axis passes through focus. Parallel to principal axis passes through the focus. Then we will get the image at the focus and it is point size. Okay, real and inverted image, but size is point size and highly diminished. One more, the most important, see, before we have seen all the objects are placed in front of the mirror and images will also be get in front of the mirror. But in this case, object is in front of the mirror, but image will come beyond the mirror, behind the mirror. When object is placed between pole and the focus. Okay, between pole and the focus, object is here. We are taking one incident ray through center of curvature and one passes through the parallel to principal axis, passes through focus, and they appear to meet somewhere here. Reflected rays appear to meet somewhere here. So you will get here virtual. In all cases, remaining all cases, we will get real and inverted, but for only this case we will get virtual and erect, and image will be larger than the size of the object. Except this, for all we will get in front of the mirror only. For only this we will get behind the mirror, and the nature of the image is virtual and erect. Again, if we place the object at focus, we will get image at infinity. And how it will be the nature? Real, inverted. If we place the object between F and C, we will get beyond the center of curvature. Nature of the image, real, inverted. At center of curvature, we will get image also at center of curvature. What is the nature? Real, inverted. If we place the object beyond center of curvature, we will get the image at between F and C. Nature of the image, real, inverted. If we place the object at infinity, we will get image at focus, it is real and inverted. If we place the object between pole and the focus, we will get the image behind the mirror. Nature is virtual and erect. More important, we need to know about the sign convention. How will be the object, image, focus, height of the image, height of the object. U means object. Always object distance of the object will be negative. Why we are taking negative? Where we will place the object? In front of the mirror. We have said in front of the mirror all the distance will be measured in negative. So object distance is negative, and image distance we have seen for all the cases we are getting the image also here only, and we are getting downward, real, inverted. We will take a negative value. For real images we will get negative. Only for one case I have said, in last case I said we will get behind the mirror. For that virtual mirror, for that only we will take positive. Remaining all we will get negative. And focus, if we see, we are incidenting light rays like that. Where the focus, where we will get focus opposite to the direction of the incident. Incident rays are passing here, going like this, but incident rays are getting in opposite direction. That's why focus is negative. And height of the image. Height of the object. Height of the object. Where will we place the object? Here means we will take this like this. We will measure now how these are positive values. So we will get height of the object is positive, and height of the image we will get downward. What are these coordinates? Negative. Negative values we need to take. Don't confuse object. No, for this how we will measure? Like this we will measure. What are the coordinates? A positive or negative? Positive. So object will be positive. Negative we will get downward. Means we need to measure like this distance. We will get negative values. Clear? Object distance negative, image distance negative for real, positive for virtual, focus is negative, height of the image for real images negative, virtual image positive, height of the object always positive.